So good afternoon, everybody. I am Pierre-Aimé Agnel. I am the manager for the research and development projects in Scilab Enterprises. I will talk about Scilab technical presentation, so what we have done currently, what we are planning to do, a few words about the developments that were done very recently, and a more general approach to the Scilab as a platform. Scilab as a platform, we've seen many presentations from these 2 days. You see Scilab as a workstation for your engineers. It has script language capabilities, a lot of functions for plotting 2D, 3D visualization, users interface, a nice user interface from the current release, possibility to do GUIs, we've just seen one, an incredible one. We have data processing, so data processing is very important. We've seen that most of you, when you do your scripts, need to get data from many places, files, databases. We've seen some big data presentation this morning, so very interesting to have on the platform. We have Xcos for systems design, hybrid systems design, an API that allows to extend the possibility of Scilab in an infinite way, as many codes as there is, and specific functions for mathematical computation, for signal processing, for statistics, etc. All these can be further extended, so on different platforms, Unix, Windows, and Mac OS, and can be extended to with other tools. So we have many other domain applications, domain-specific applications, data interface modules. We've just recently released one for a client, a VISA module. Other proprietary tools and applications that you can link to Scilab. We have, for example, LabVIEW, iSight, other languages, Python, UML, etc. And this will grow in the future. All this platform and this extension is done to build your applications, or your batch script if you're running on a business that needs to have some proper information at the right time. And we've seen it from the presentation from many partners. We also have the possibility to deploy all these scripts to your engineers across a company or to students for education purpose with our Atoms servers and repositories. So you see this as a platform. This is the current Scilab you see. We've released in April Scilab 5.5.2, which is to us the stablest version of Scilab we've ever built, and so we're very proud of it. We've added new graphic features mentioned by our friends from the CEA. So this is the current release. You have this Scilab now. A word about a few developments we've been doing in the year for research projects or for client projects. We have FMI support so functional mockup interface support in Scilab that is available for Xcos for Scilab. That is a problem for co-simulation or model exchange. Allows the users and engineers to build a module in Xcos or to import a module from other tools into Scilab and Xcos and execute the code. It's a very good solution for intellectual property issues or for interoperability issues. We also have developed a VISA module. It's just released 2 days ago, so I don't have the slide here for a client. So we built from the FISA virtual interface from the National Instrument. That is also available that was a client project. So we've done some work and we are proud of it. So Scilab now is the 5.5 family. We've seen release in April 2014, October 2014 was a minor release, this current release in April. You're waiting for something. And this is what you're waiting for. We have a Scilab 6 release this year, the 1st of October 2015. Prior to this release, you will get some beta version during August, so you'll be able to test it extensively and give us your feedback. You have had this remarked in the previous years, and we've taken it into account for our future release. We want to get a faster release cycle for the minor fixes that you can see in Scilab. So we will bundle the minor fixes and major bug fixes to have quicker release in the year, during the year, and to have a major release every 6 months. So now, for features of the ScilabTEC family. We have improved the data processing of Scilab. So the memory management and the core of Scilab is now built on a C++ library with dynamically allocated memory. You will no longer see the stack size problem. Memory is completely dynamic, so depending only on your machines. We have done a lot of work on the interpreter of Scilab, so to have an abstract syntax tree, which is very good for, we'll see all the possibilities that we have. And we have built some just-in-time compilation, and we'll bring it into Scilab to get faster code from your Scilab scripts. Some examples. Here, you'll see an example on Scilab 5.5 with first stack size max. I want the maximum memory possible. I try to do a big computation, bam, stack size exceeded. That big problem you've all seen. This, on the right-hand side, is from ScilabTEC. No problems. Not even a stack size function to add. You have better syntax. Now we have included a parser with an interpreter working on an abstract syntax tree, so that the Scilab script is parsed before being executed, not as just the interpreter going line by line, but as the full script being read and all the parsing error being discovered before the actual execution. And you have now a very nice messages telling you exactly on the line where is the parsing error. That will get you better code. The language evolves. We have C-style comments for branching, debranching code that exists. We've added this possibility in Scilab. Recursive extraction, so if you want to perform a computation but you only need, for example here, the spec, I've taken the eigenvalues of my matrix A, only the 5 first. This is recursive extraction. This is easy on your script. We have added a new switch syntax that's closer to the one from the MathWorks for your script interoperabilities. And also shortcut operations directly from the line. So now the AND and OR can be doubled for shortcut operations, so you don't have to process all the line in your scripts. We've also removed the limitation from the Scilab script language. Maybe not all of you know about this, but if you had variables that were longer than 24 characters, you had problems. You no longer have the problems. I created a very long variable here on my Scilab 6, and you see it's great, no problems. My functions, if you had overloading functions with a type that was longer than 9 or 8 characters, you had problems. You could not execute it properly. Now, no problems. Your arbitrary long type can be as long as you want, and you have a good execution on it. Data types, cells, something that people asked us. We have a MATLAB script. We cannot go to Scilab easily because we have cells. Now you have cell support. Entire cell support is the same syntax as in MATLAB. Same extraction from the cells. Very good for heterogeneous structures in Scilab scripts that you want. It's there. We have added a lot of support for structures that were considered slow on your scripts. Now they're native and they're primitives of Scilab. So structs, multi-dimensional arrays, hypermatrices in Scilab, they're now of the type of the primitive they represent. So you have faster execution, and this is the same for every primitives of Scilab. We've added the multidimensionality. We've also added int64 and uint64 types for those of you who are doing a lot of computation on integers for example, embedded programs, embedded programming. So this is now added on Scilab 6. An important feature we will release in October is the just-in-time compilation. The just-in-time compilation, from the first test we've had, and I don't have the picture of the developer here, but he said, you could put the picture, because I'm confirming this. We have some very good speed ups on most iterative loops that you have on Scilab. So the hassle of trying to vectorize every code you have all the time and seeing the answer that please vectorize your code, you have some sort of new thing that accelerates it directly. But it's more important to note that this just-in-time compilation, based on the LLVM, very good references, LLVMs from Apple, and we have a good consortium behind it, will allow us to move forward to even better just-in-time compilation and analysis of the code structure and code generation, etc., etc. That will help us to build a Scilab for high-performance computing or other very current research fields. This just-in-time compilation we've seen from Silcan, our partners in Richelieu here, was initiated by this project, the Project Richelieu. We worked with the several partners that we thank for their contribution. And thanks to the people in Scilab, we'll be able to add also all these features in Scilab 6. Now for Xcos. We've had a conversation with some people saying, yeah, Psychos was Xcos, Psychos. Now we have an Xcos built on a better model, data model here. Data is unified and shared entirely. You'll have no problems with very, very big diagrams. You don't have a duplication of the diagram structure across Xcos on one side, Scilab on the other side for your code generation. All is unified, kept in one place. It leads, obviously, to better simulation performances. And it also leverages all the possibilities that exist in Scilab 6. I've talked about just-in-time compilation. I've talked about all the syntax improvements and the performances that we get from Scilab 6. All this is going to benefit to Xcos. We've released a 5.5.2 with minor bug fixes, a few improvements. So most of the improvements that are waiting here will be included in Scilab 6. We have some new graphical features awaiting, some scatter plotting possibilities, implicit plots. Here you have a graph of streamlines built from a differential equation directly. Plotting the plot syntax is very easy. You plot the text for the differential equation, and you get this. So, new graphical features. So the question you have is, okay, you're going to do a Scilab 6. What about my former scripts? I'm afraid maybe you have changed the syntax too much. I fear about it. So you have questions about your backward compatibility. We have removed a few things from the syntax that we considered very bad, no longer valid. So for example, the non-homogeneous use of quotes and single quotes, double quotes and single quotes for text. This is going to be deprecated. We have the new Scilab open data format that is based on the HDA5 libraries. That will be the only this optimal binary format will be supported. So the former one that we actually deprecated in Scilab 5.5 will be removed entirely. The old API is removed in favor of the new one. So the one we built, and we have not changed the interface so that your code will still work with the Scilab API. We've simply added new features, for example, for cells or for user types, specific user types. So nothing was removed from it, from the Scilab API. Only things were added in Scilab API 6.0. From our test on our own code, we had only 1% change. 99% of our existing scripts did not move. So if you had questions about your backward compatibility, here's our answer. And in performances, we've seen that, for example, on the extraction, the parsing, etc., we gain a lot on Scilab 6. We'll publish some benchmark prior to the release, so that you have the idea. So what's our roadmap? Where are we going to go from now? We have a new abstract syntax tree, so a new language interpreter, and we have JIT compiling for Scilab 6. We have a new core with a dynamically allocated memory. So we want to improve again these capabilities to allow us to, for example, switch the functions at runtime to select depending on the architecture or the machine you're running on, to see some optimization done, parallelization. So we want to build a Scilab that is fit for distributed architectures, that is fit for code generation, all the work that some people have done on parsing. Now we have an interface and visitors to our syntax tree so that you can, for example, do type inference, size inference on your scripts. And code generation will be easier thanks to this. And also the possibility to have your memory managed externally, so have like pointers to a database and call variables from outside. That gives us big data capabilities. So in the future, you'll see more, and this is on the research we are doing currently, more HPC and big data capabilities. And of course, we promised it, a faster release cycle so that you have more stability, and if you want to add features, if you want to correct bugs faster, we are here. We want to be more agile in this. And we dedicate ourselves to be that agile. I'd like to thank you, first, for your attention, for your many contributions to the Scilab software, to your involvement to this open source software, to the things that we build together, and I would also like to thank all the team that's in the room here that helped us build a good Scilab. So thank you very much, and if you have questions.